let's dive into this whole world of Amazon VPCs. It's easy to get lost in all the technical details, right?
Yeah, absolutely. It can be a lot to take in.
We're going to break down exactly what you need to know about these virtual networks, why they're so important, how they actually work, and how you can lock things down with all the security features.
It's really like building your own custom network in the cloud with its own rules, its own safeguards, and the best part is you have complete control over it all.
Okay, so it's not just like spinning up a server on AWS and calling it a day.
No, not at all. Think of a VPC like building a house. You get to decide the layout, the security system, who has access, It all starts with carving out your own little space in that vast AWS cloud.
Okay, I'm starting to get why this is so powerful, but let's break it down. What are those fundamental building blocks of a VPC?
Well, first up, you have subnets. These are like smaller neighborhoods within your larger VPC network, each with its own IP address range. You can have public subnets for resources that need to be accessible from the internet, like web servers, and then private subnets for your more sensitive data, like databases.
So it's like zoning a city. You wouldn't want to put a factory in a residential area, right?
Exactly. And just like in a city, you need ways to connect those different neighborhoods. That's where things like internet gateways and routing tables come in.
Okay, so we've got our neighborhoods with subnets, and we can connect them out to the internet. But what about different types of VPCs? The stuff we've been looking at mentions default and non-default VPCs.
Right. It's like choosing between a pre-built house and building one from scratch.
Okay.
A default VPC is automatically created for you in each AWS region. It comes with some basic configurations like subnets and an internet gateway to get you up and running quickly.
Sounds convenient.
Bliss.
But what if I want more customization?
Well, that's where non-default VPCs come in. You have complete control over the IP address range, the number of subnets, and how it all connects. It's like having a blank canvas to design your network exactly how you want it.
So default is for speed and simplicity, and non-default is for when you really want to be the architect of your own little cloud kingdom.
Precisely. But keep in mind, even with a default VPC, you can still customize it to a certain extent. You can add more subnets, adjust security settings.
So it's not an all or nothing choice.
No, not at all. It's about finding that balance between ease of use and control. And speaking of control, one of the most critical aspects of VPCs is security.
Okay, let's talk security. I'm guessing it's a bit more complex than just building a firewall around your entire VPC, right?
You're absolutely right. It's all about layers. You have security groups which act like mini firewalls for individual resources, like your EC2 instances. They control inbound and outbound traffic based on ports and protocols, ensuring that only authorized connections are allowed.
So if I only want to allow SSH access to my web server from my office IP address, I can set up a security group rule for that.
Exactly. It's like having a bouncer at the door of your web server, checking IDs and only letting the right people in.
That's a great analogy. But the documentation also mentions something called network ACLs. How do those fit into the security picture?
Think of network ACLs as a broader security layer, controlling traffic at the subnet level. They act like a security checkpoint for all traffic entering or leaving a subnet, filtering it based on rules that you define.
So if security groups are the bouncers at the individual resource level, network ACLs are like the security guards at the neighborhood entrance.
You got it. They work together to provide comprehensive security for your VPC. It's like having multiple layers of protection for your home, from the front door lock to security cameras and motion detectors.
Okay, that's a much clearer picture. Security groups for granular control at the resource level, and network ACLs for broader control at the subnet level.
Yeah.
But there's another key piece to this security puzzle. IP addressing, right?
Absolutely. And this is where things get really interesting. When it comes to managing costs and security in your VPC, VPCs use both private and public IP addresses. And understanding this distinction is really crucial for both security and cost management.
Okay, so remind me again, what's the difference between a private and a public IP address in the context of a VPC?
Think of it this way. Within your VPC, all your resources can chat with each other using private IP addresses. It's like those internal phone numbers within your company. They work great inside, but you can't use them to call someone outside.
Okay, so those private IP addresses keep all that communication within the VPC nice and contained and secure.
Exactly. And the best part is, you don't get charged for those private IP addresses by AWS. Now, if you want your resources to talk to the outside world, that's when public IP addresses come into play.
So a public IP address is like having that public-facing phone number that anyone can call.
That's the idea. Public IPs let your resources be directly accessible from the internet, but there's a catch. AWS does charge for the use of public IP addresses, so it's all about finding the right balance.
Yeah, that makes sense. Use private IP addresses as much as possible within your VPC to keep things secure and cost-effective, and then only assign those public IP addresses to resources that absolutely need to be accessible from the internet.
You got it. And there are some clever ways to manage this. For instance, you can use what's called a NAT gateway. It acts as a middleman, allowing instances in a private subnet to initiate outbound connections to the internet without having a public IP address themselves.
So it's like having a receptionist who can make calls on behalf of employees who don't have their own direct lines.
That's a great analogy. That NAT gateway masks those private IP addresses of your internal resources, but it still allows them to access the internet for things like software updates or fetching data.
Okay, so that's a pretty clever way to maintain that security but also manage costs.
Yeah.
Now, what about those scenarios where you need to connect your VPC to other networks, like another VPC or even your own on-premises network?
That's where things get really interesting. When we talk about building those hybrid cloud environments, let's start with VPC peering. It's a way to connect two VPCs together privately and securely, allowing resources in those VPCs to communicate with each other, as if they were on the same network.
So it's like building a bridge between two separate cloud kingdoms.
Precisely. And all the traffic between those VPCs stays within the AWS network, so it doesn't go over the public internet, which helps improve performance and reduce costs.
So I could have my application servers in one VPC talking to a database in a completely different VPC, all without exposing that traffic to the public internet.
Exactly. It's a fantastic way to segment your applications and your data while still maintaining that seamless connectivity.
Makes sense. Now, what about connecting my VPC back to my own company's network? Like if I have some sensitive data, or applications running on servers in my own data center.
For those scenarios, AWS offers a service called AWS Direct Connect. It establishes a dedicated private connection between your on-premises network and your VPC. Think of it like building a high-speed tunnel straight into your cloud environment.
So it's a much faster and more secure connection than going over the public internet.
Absolutely. And it's often used for applications that require really low latency, or those that need to transfer massive amounts of data between your network and your VPC.
This is starting to sound like a network engineer's dream. All these different ways to connect things together.
Yeah.
But I imagine it could get pretty complex to manage all of this.
It can. But AWS provides tools and features that help make things a bit easier. And one important concept to keep in mind is high availability, especially when you're designing mission-critical applications.
Yeah, right. No point in building this great network if it all comes crashing down if one single component fails.
Exactly. And that's where availability zones come in. These are like physically separate data centers within a region. And by spreading your resources across multiple availability zones, you can create redundancy and protect your application from those single points of failure.
So if one availability zone goes down, my application can just keep running in another one.
That's the goal. And VPCs make it really easy to leverage those availability zones. So when you create subnets, you can choose which availability zone each subnet belongs to, ensuring that your resources are distributed for that high availability.
Okay, that makes sense. So we've covered how VPCs work, all the security features, how they connect to other networks. I'm really eager to see how all this comes together in some real-world scenarios.
Great. Let's shift gears and explore some practical examples of how people are using VPCs to build everything, from simple websites to complex multi-tier applications.
Okay, so let's get practical here. Can you give me an example of how all these VPC concepts actually come together in a real-world scenario?
Sure. Let's say you're building like a simple e-commerce website. You could set up a VPC with two public subnets, each in a different availability zone for that redundancy we talked about.
Okay, so if one availability zone goes down, my website stays up and running in the other one. Smart.
Exactly. And in each subnet, you would launch a web server instance and then put a load balancer in front of them to distribute traffic.
Okay, so even if one web server crashes, the load balancer can automatically redirect traffic to the other one, and my website stays up.
Precisely. Now for the database, which doesn't need to be publicly accessible, right? You would put that in a private subnet within the same VPC.
So my web servers in the public subnets can talk to the database in the private subnet, but the database itself is shielded from the open internet.
You got it. And to allow that database to communicate outbound to the internet for things like software updates, you would use a NAT gateway.
Oh, right. That way the database can get what it needs without exposing its private IP address. So we've got high availability, security, and cost efficiency all baked into this design.
Exactly, and this is just a basic example. You can get way more sophisticated by adding things like security groups to control traffic between the web servers and the database, or network ACLs to further restrict access to that private subnet.
So as my application grows and my needs evolve, I can kind of layer on more of these features and really customize my VPC to fit what I'm doing.
Absolutely, that's the beauty of VPCs. They're incredibly flexible. You can start simple and gradually add complexity as you need it.
That makes a lot of sense. Now, what about those scenarios where I need to connect my VPC back to my own on-premises network? Like, what if I have legacy systems or sensitive data that I can't move to the cloud just yet?
That's a pretty common use case, and VPCs offer several options for that. One approach is to use a VPN connection, which basically creates an encrypted tunnel over the public internet between your on-premises network and your VPC.
So even though that connection goes over the internet, the data itself is still protected.
Exactly. It's like sending a confidential document through a secure courier service. Now, for even faster and more reliable connections, you can use AWS Direct Connect, which establishes a dedicated private link between your network and your VPC.
Got it. So if I have a lot of data to transfer or I need super low latency, Direct Connect is the way to go.
That's right. It's often used for things like real-time data replication, or even extending on-premises networks to the cloud for disaster recovery.
This has been incredibly helpful in understanding the practical side of VPCs. Any final words of advice for someone who's just starting out with all of this?
I'd say start with the basics, and don't be afraid to experiment. Spin up a test VPC, play around with different configurations, see how things work. The AWS free tier offers resources you can use to learn without breaking the bank.
So it's like a virtual sandbox where I can try things out and learn from my mistakes.
Precisely. And once you're comfortable with those fundamentals, you can gradually add more advanced features, explore different use cases.
Great advice. Well, on that note, it's time to wrap up our deep dive into Amazon VPCs. We've covered a lot of ground, from those basic building blocks to real-world examples and those practical tips that you just gave us.
It's been my pleasure. Hopefully this has given everyone listening a really solid foundation to start building their own secure and scalable cloud networks on AWS.
Yeah, and remember, VPCs are so versatile, and there's always something new to learn. So keep exploring, keep experimenting, and unlock the full potential of this amazing technology.
Until next time, happy networking.